Let us solve the following. So write the answer in interval notation. So we have here 2x squared plus 9x minus 5 greater than or equal to 0. X times x plus 2 is less than negative 2. X squared greater than or equal to 7. 2 over x less than 4. And then x minus 2 quantity squared all over x plus 1 times 2x minus 1 greater than or equal to 0. Let's start with the first problem. So here, one side of the inequality is already equal to 0. So we're going to solve this by sine graph or sine diagram. And the first thing that we need to find are the x values that will make this left-hand side equal to 0. And we can easily determine that one if we factor out the expression. So let's factor out this one. This is just 2x, and then factoring by trial and error method. So you have here plus 5 and then minus 1. And you can check the factorization by FOIL method. So you have here 2x times x, so that is 2x squared. And then 10x plus negative x, so that is 9x. And then negative 1 times 5, it is equal to negative 5. So that is the correct factorization. And then greater than or equal to 0. So the values of x that will make the left-hand side 0 are, of course, this first factor here is equal to 0 when x is equal to 1/2. And this second factor is equal to 0 when x is equal to negative 5. So we have to exclude these numbers, negative 5 and positive 1/2, because the left-hand side has no sign. Okay, so we have to exclude these numbers first. So now we can divide our real line into the following intervals. We have negative infinity to negative 5, and then negative 5 to positive 1/2, and 1/2 to infinity. And for each of this interval, there is only one sign for this left-hand side. It is either positive or negative only. Because if this could be positive, could be both positive and negative, then that means there will be another x value that will make it 0. But these are the only x values that will make the left-hand side equal to 0. So this, for example, in this interval, this product here is either positive only or negative only. So it is enough to just choose a test value. Let's say a number in this interval, let's choose negative 6. So if we choose negative 6 here, and let's find the sign of this product. You have here 2x minus 1 times x plus 5. So the sign of this one, so if x is negative 6, this factor here, 2x minus 1 is negative, and then times negative 6 plus 5, which is again a negative number. So negative times negative, this will give us a positive product. For this second interval, again, we just choose a test number. Let's say 0. It's very easy to find the value of the product when x is equal to 0. So if x is equal to 0, this one is negative 1. It's a negative number times a positive number. It's positive 5. Negative times positive, this gives us negative. And when x is equal to, let's say 1, so let's choose a test value here. Let's say 1. Then the first factor will be 2 minus 1, so that is positive, times positive. So that will give you a positive product. Since we're looking for values, this inequality here includes equality sign. Okay, so now let's find the solutions to this inequality. So we're looking for x values that will make this greater than 0. Greater than 0 means it's positive. or it is equal to 0. But what are the x values that will make it 0? These two values here. So therefore, the answer to this problem will be, so we have to choose this one here, okay, and also choose this one, and the x values that will make it 0. So we have to choose this -5 and then 1/2. But the interval corresponding to this positive sign here is the interval, this one here, -∞ to -5. And then for this one here, the interval corresponding to that sign is this interval, which is 1/2 to infinity. So therefore, our solution set in this case is the interval -∞ to -5, including -5, union with 1/2, including 1/2 to infinity. Any questions to this solution? So what if we're given an inequality, instead of greater than or equal to 0, it is less than 0. So you have here 2x squared plus 9x minus 5 less than 0. So in this case, it is strictly less than, okay? We have the same sign graph here. So the x values that will make this left-hand side equal to 0 are these x values, okay? You have to choose the negative sign. So the solution for this problem will be, solution set is just the open interval -5, 1/2. If you're given this one, the first thing that we need to do is to make one side of the inequality 0. So we move this -2 to the left-hand side of the equation. So keep in mind that when you move a term from one side to the other side, you have to change the sign of the term. So from -2 to +2. And then we remove the grouping symbol, we'll get x squared plus 2x plus 2. And we're going to use sign graph to solve this inequality. First, we have to exclude the x values that will make this left-hand side equal to 0. And we can use, since this is not factorable, we can use quadratic formula. And when we use quadratic formula, we see that the solutions are imaginary solutions. So they are not real numbers. So there are no exceptions here. So, okay, there are no real numbers x that will make the left-hand side equal to 0, which means that the value of this is either positive only for all real values of x, or it's negative only for all real values of x. And to determine that one, we plug in a test value. Let's say x equals 0. You plug it in to this expression. So you have 0 squared plus 2 times 0 plus 2. So that is +2, which means it's positive on the entire interval. So therefore, this is always positive for all values of x. So there is no x value that will satisfy this inequality. So this expression less than 0. So our solution set is the empty set, or set containing nothing. So let us solve x squared greater than or equal to 7. Similar to the previous problem, the first step is to make one side of this inequality equal to 0. So we'll get x squared minus 7 greater than or equal to 0. And then we're going to make our sign graph in this case. Okay. So first, we have to find the x values that will make this left-hand side equal to 0. So you can solve the quadratic equation, let's say x squared minus 7 equal to 0, or you can factor this out into x minus square root of 7 and then times x plus square root of 7 greater than or equal to 0. Because you can write 7 as the square root of 7. and it becomes difference of two squares. Okay, so the factorization will be x minus square root of 7 times x plus square root of 7. So the values of x that will make the left-hand side 0 are the following. So we have negative square root of 7. So we have to exclude this. And then we have positive square root of 7. We have to exclude that one. Okay. Now we have to consider the intervals negative infinity to negative square root of 7, the interval negative square root of 7 to square root of 7, and the interval square root of 7 to infinity. So we want to determine the sign of the left-hand side, which is x minus square root of 7 times x plus square root of 7. So the sign of this one, so to determine the sign in this interval, we choose a test value like negative 3, because negative 3 is less than negative square root of 7, because negative 3 is negative square root of 9. So we can use that as a test value here, negative 3. So if x is equal to negative 3, this is a negative number, and then times this is also a negative number, because negative 3 is negative square root of 9. So negative times negative, that will give you positive. To determine the sign in this interval, we can choose, let's say, x equals 0. And when x is equal to 0, it is clear that this will be negative times positive. So you'll get a negative product. And for this last interval here, so when we choose 3, you may choose 5. Okay, so let's choose 5. When x is equal to 5, you'll get positive times positive. So the product is positive. And what are we looking for? We're looking for x values that will make this product greater than 0 or equal to 0. It is greater than 0 if greater than 0. So that means we have to choose this one and this one, greater than 0. So these numbers here are solutions. Or this product is equal to 0. So it's equal to 0 when x is equal to negative square root of 7 and positive square root of 7. So therefore, the solution set is this set negative infinity to negative square root of 7 union with square root of 7 to infinity. Okay, now let's solve problem number 4. 2 over x is less than 4. The common mistake of students here is to multiply x to both sides of this inequality. Why can't we do that? We cannot multiply x to both sides because we don't know the sign of x. X could be positive, x could be negative. If x is negative, then it will change the inequality direction. If x is positive, then we have to keep this inequality. So to avoid that problem, it's better not to multiply variable terms to both sides of an inequality unless you know the sign of the variable term. So in this case, we don't want to do that because we don't know the sign of x. So what we're going to do here, similar to the previous problems, we make one side of the inequality equal to 0. So we move the 4 on the right-hand side to the left-hand side. So it becomes 2 over x minus 4 less than 0. Now, we make the left-hand side as a single fraction. Okay, so we combine it into a single fraction. We'll get here 2 minus 4x less than 0. And now this is similar to an example that we solve in class. So next, we want to draw our sine graph. Okay. So again, we find the x values wherein this expression on the left has no sign. So it doesn't have a sign if it is either 0 or does not exist. So this is equal to 0 if the numerator is equal to 0. And the numerator is equal to 0 when x is equal to 1/2. So you can solve that equation. 2 minus 4x equals 0. You'll get an x which is equal to 1/2. So we have to exclude 1/2. And what makes the denominator equal to 0? So x equals 0. So we have to exclude x equal to 0. So for these values of x, it is clear that this expression on the left has no sign. It is neither positive nor negative. That's why we're excluding these values. And now we're ready to determine the sign for all the other x values. So what are the intervals that we are considering here? We have negative infinity to 0, 0 to 1/2, and then 1/2 to infinity. So again, we want to determine the sign of the left-hand side, which is 2 minus 4x all over x. So to determine the sign, it's enough to just pick a test value from each interval. So let's say in this interval, let's choose -1. If x is -1, this will give you a positive number. 2 minus -4 times -1, that is positive, over negative. So that will give you a negative quotient. Now, if you choose a value here, let's say 1/4, okay? When x is equal to 1/4, 4 times 1/4 is 1. So 2 minus 1 is positive. Divided by positive, you'll get positive. And for the last interval, we may choose, let's say 1. When x is equal to 1, this is 2 minus 4, so it's negative over positive. So that is negative. And we want to find the x values that will make this left-hand side less than 0. So if it is negative, then it is clearly less than 0. So we have to choose this negative sign and negative sign. So the solutions are these two intervals. This is strictly less than, so we don't have to check whether these two are solutions. So the solution set here is the set negative infinity to 0 union with 1/2 to infinity. Okay, now let's move to this last problem. So let's solve this inequality here. It is already in factored form, so we can immediately draw our sign graph. So we have to exclude the x values. What? So x values that will make the numerator 0 or the denominator equal to 0. So the numerator is equal to 0 when x is equal to 2. Okay, so x equals 2, we have to exclude that one. The values of x that will make the denominator 0, so 1 is x equals -1. So that is here, okay? And then 2x minus 7 is equal to 0, means x is equal to 7 over 2. So we have to exclude 7 over 2, which is the same thing as 3.5. Okay. So now we consider the intervals negative infinity to -1, -1 to 2, 2 to 7/2, and then 7/2 to infinity. So again, we choose a test value from each interval to determine the sign of the left-hand side, okay? Sign of left-hand side of this inequality. So let's choose a test value from each interval. So let's say here, let's choose -2. Here, let's choose 0. Here, let's choose a 3. And then this one, let's choose 4. Okay. So when x is equal to -2, as you can see here, the numerator is quantity squared, x minus 2 quantity squared. So when you square a number, that is always greater than or equal to 0. Okay. But we're excluding here the values of x that will make it 0. So this is always positive. So since this is always positive, when you're looking for the sign of the left-hand side, you may just ignore this numerator here. So just find the sign of the denominator because the numerator is always positive. Whatever the value of x here, it's always positive. Okay, so just focus on the denominator. In this case, when x is equal to -2, so that is negative times negative, you'll get positive. When x is equal to 0, you'll get positive times negative. That will give us negative. When x is equal to 3, so this is positive times 2 times 3 is 6 minus 7. So negative, positive times negative, it will give us again negative. And then when x is equal to 4, positive times positive, so that product is positive. So this example shows you that the signs are not necessarily alternating. So you can have plus and then minus minus and then plus. It is not always alternating signs. So what are the solutions to this inequality? So we have to find the x values that will make it greater than 0. So these are the values that will make it greater than 0 or equal to 0. Equal to 0. So equal to 0, the x value that will make it 0 is only x equals to. Okay, so only x equal to positive 2. So the solutions are this one, this interval, and then positive 2. So how do we write our solution set? Our solution set is -infinity to -1 union with a set containing a single number. So you have here set containing 2 union with 7/2 to infinity. Well, you may write this singleton set here as a closed interval 2 to -2. So you may write this set containing 2 as 2, 2 as an interval. So they are equivalent. So this is the solution to our inequality.